Hi everyone, welcome back to another Calculus 12 video. We're doing applied maximum and minimum problems today, so we get to apply basically all the skills we've learned in this unit, chapter 4 and 5. And it's one of the most important applications of derivatives. It occurs in the solution of optimization problems, and optimization just means max and min problems. So you really don't necessarily need this, but I just thought it would be nice for you to have a series of steps to sort of summarize what we're looking for or how to go through this. So step number 1, determine what it is you're trying to find. I find a lot of times that's the first part of it, is understanding what you're looking for. And assign variables to the unknowns. That you've been doing for years, so I think you'll be okay with that. Number 2, determine an equation for f of x. So that's taking the sentence and translating it into math. Number 3, find the derivative for f of x. And number 4, use the second derivative test. So no new skills here, but it is just taking all the stuff we've done and looking at actual examples of how this might show up or how it's used in actual real life. So in the first example, it says a rectangular box with a square base and no top is to have a volume of 108 cubic inches. Find the dimensions for the box that require the least amount of material. So if I go back and I pull up these steps, it says, determine what it is you are trying to find and assign variables to the unknowns. Well, we've kind of been doing this since grade 8. We called it a let statement. I don't know if you're familiar with that vocabulary, but that's what I'm going to use here. So for step number 1, let's let x, we're familiar with x, so I'm just going to use that, equal, well, if I take a look at this, we're talking about a rectangular box with a square base. So let x equal the length of our square base. So there's the first part. The box has no top and it has a volume of 108 cubic inches. Okay, I'm not the best artist, but I think I can handle drawing a box. But there we go. Let's make that x, and oh no, see, I actually didn't do it right. Let's do this. I'll try to draw it three-dimensional, and I feel like going over it multiple times lessens how bad it is, and it makes me look a little bit better. So this side would also be x. Whoops. And then how far up it goes, we could label that as h. So let's let h equal the height of the box. And I do recommend, well, first of all, I will be looking for this. I do want you to actually write it down. You could just say a equals or x equals or h equals, but do put somewhere what it is, because oftentimes you go through the calculations, by the end of it you have no idea the number you spat out, what it represents or what it is. So do this, and then if it says it has a volume of 108 cubic inches, so we have a volume of, well, let's look at this. We know that volume is length times width times height. So do you see in this case it would be x squared h when we look at this part here. But we also know that that is 108 inches cubed. I feel like you can't really read that. 108 inches cubed, just like that. Okay, so there's a part of it. We have the formula done for the volume, so that's all good. Find the dimensions for the box that requires the least amount of material. Okay, so if we think of the least amount of material, let's assume it's a cardboard box, then for the least amount of material, we're clearly talking surface area, right? So you can think of it either as like putting wrapping paper around a box, or you can think of the actual cardboard flat layout that we're putting together to make a box. Any which way that we look at it, we know that we want a formula for surface area. So if we get something where the formula isn't given, it'll usually be stuff that you know. I'm going to trust that you all know how to do both of these, volume and surface area. But if there is ever anything, you can ask or it'll be given. I want to know that you know how to do the calculus and the work with it. I'm not going to care too much about the minor details about this stuff. If we're dealing with surface area, we do want to include the bottom here. Just going to scribble that in. I hope I don't make this worse. But so that would be x squared, as we can see. Plus, we would also have, I'm going to do this like there. There'd be a side back there and a side back there. So we would also have 4x times h, because if we look at it, we have the x there, and then the height going up would be h, so you'd multiply the two together. And that together takes care of the whole thing. So I know that I'm going to be working with these formulae, I guess I could say. And another way that I can, like if I analyze or take a look at these, both of these formulas, that, and then this whole thing, I have an x and I have an h. So I know that it's easier for me, or I kind of have to, get it down to only working with one variable. So, although I have options of how I can do this, when I look at this, I think, okay, if that x squared h is equal to 108, I can isolate for h. So my h would be equal to, if I take this 108, and I divide it by the x squared there. So over x squared. And I feel like we need to make that thicker to make things consistent here. So over x squared like this. So then, now that I know that h is equal to all of this, I can take that and plug it in for my h value here. So as I go through here, I can say x squared plus 4x, and then into my brackets here, I'm going to plug in 108 over x squared, because we know that that's the same thing as h, as we just worked our way through back there. Okay, we did that, we're doing that, and then we're going to find the derivative. But we're going to clean this up a little bit before we do that. X squared, whoops, that is the wrong color. We would have x squared plus, as we see this, we can start to cancel things out here. So 4 times 108 is all I'm left with up there. So I get 432 divided by, when I divide out the x's there, I'm just left with this 1x. I'm looking around at this massive B that is circulating around me. Anyways, so this is our formula. This is what we're going to be working with. So at this point, that we can say is our f of x. So our next job is to take the derivative. So if that's my f of x, then I want f prime of x of this thing. And I know when I do f of x prime of this thing, I'd get 2x for this one here. And as I go to this one here, it would be minus, do you see that this is like saying 432x to the negative 1? So I could say minus 432. Over x squared. I feel like I'm just going to write it beside here to show you quickly. So that would be like saying 432 to the x to the negative 1. So remember, for power rule, I'd bring down the minus 1, and then that would become x to the minus 2, and I subtract off the 1. Subtract off another one off the minus 1 that was already there. So that's how we're getting this. I know that you're all fine with that. I just thought maybe I should explain it. And then we want to set this equal to 0. So I'm going to get lazy, and I'm just going to erase this, set it equal to 0. And when we do set it equal to 0, we would get 432 Well, let's make this a little bit easier to work with. Do you see that I could multiply both of these by, multiply that by x squared over x squared, And the reason I'm doing that is so that I can put them all together. Like I would end up getting 0 equals, and I'd get 2x cubed minus 432, and the whole thing would be over x squared. But because I've done this, I'm being sneaky because I can just get rid of that because I would multiply it by the 0 after in order to get it there. And then when I bring over the 432, I would divide that by 2, and then I would cube root that, and I'm going to trust that you all know how to do that, but we end up getting x equals 6 after all that work. So x equals 6 would be an example of our critical point. Okay, so we're getting there. There's the first little bit. And then the next little bit, I'm going to move up to here to get to the next little bit so we can see the original information as well. But now we want to find our second derivative. So as we are looking for our second derivative, again, I would go back to my first derivative that I found here, and oh, that was back here, and I ended up getting rid of it. So it was 2x minus 432. So our second derivative is going to be 2 plus 864 over x cubed. Okay, the reason why is I feel like I maybe messed this up a little bit for you to see it clearly because I did all the work within that. And now we don't have an f prime of x written anywhere. So this, maybe I'll show you above here. Our f prime of x, before I did all this work on it, was just 2x minus 432 over x squared. So you can now see how I got that second derivative. So hopefully that makes it a bit easier for you to make sense of and to work with. And then we know when we take our second derivative, we want to take our critical point, so take 6, that value we found, and we want to plug that in. So 2 plus 864 over 6 cubed. So this f double prime of 6 ends up being equal to, when we work our way through and simplify all of this, 6, which is greater than 0. So if it's greater than 0, we know we have a local minimum at x equals 6, because if the second derivative is greater than 0, we know that that tells us that it's concave up, which ends up meaning that it's a minimum. So this is, again, taking and applying and putting together all the stuff that we've done so far. Okay, and we were looking for the least amount of material, so we're doing well. We're on our way to finding that. And then we want to find the dimensions. So we've done the work to find what we're looking for, but now we need to make sure that we're actually answering the question. We were looking, it said find the dimensions. So x equals 6, we found the length, but we also need to find the h value. So I would simply take my initial formula back here, v equals x squared h. Or there's the other one, remember we had isolated it here, h equals, maybe I'll rewrite it and I'll even color code it. H equals 108 over x squared. And if x is 6, I'm just going to take that and plug it in here. So when I work my way through that, I would find that h is equal to 108 over 6 squared, which is 36. So we get 3. So after doing all of this, we would say that the least amount of material required would be x equals 6 inches and h equals 3 inches. So the least amount of material required would be x equals 6 inches and h equals 3 inches after all that work. Okay, so I hope that that gives you an idea. As I normally explain to you after we're done, It's the only thing that can change is the formula and the equations of what you're starting out with, but all the steps and how you go about it is going to be the same. So I would like for you to work on page 188, numbers 1 to 6, 8, 12, 17, and 19. I feel like that's quite a bit. Give it a shot, and if you are finding it's too much, you can knock off the last few and just do up to 12. But that should be quite enough, and that's the last section from this unit.